I will show you how to create a player character with animations and a state machine. You will learn how to make the idle and walk states for the state machine and then transition between them. So before we begin creating our player, let's head over to our scenes folder, and in the test folder, let's create another test scene for our player. Let's duplicate this scene, just call it scene default so that we can duplicate this scene in future. Now open up test scene default and we will just delete the dirt layer off and also the nature layer. So this test scene will always be used for other components such as a player and other NPCs, and we can just duplicate that. Let's just save test scene default and duplicate that scene again, and we'll call it test scene player. Click duplicate and open up the test scene player, and now we can create a new scene. So scene, new scene, a new 2D scene, and let's just change this type. So we'll use a character body 2D, and let's then rename this to player. And in the scenes folder, let's add a new folder, call this characters, click OK. In the characters folder, create a new folder and call this player, okay? And save our scene in the characters player folder. Click on player, add child node, search for animated sprite 2D, create, and in the sprite frames, let's create a new sprite frames and then open that. And in the add frames option, let's go to assets, game, characters, and choose the basic character sprite. Open that and choose the first two, so 0 and 1 here, add those two frames, and let's just zoom in on the player and just play that. Okay, pause that animation, and then let's rename this to idle front, and then set the animation to be default on play by clicking the default button here. So this is autoplay on load, and then add another animation. We'll call this idle back. Click add frames, choose basic character sprites again, and we'll choose the second two here. Add the two frames and just play that. Okay. Add another animation and call this idle left. Add the frames and choose the left one. Play that again, zoom in a bit more, add another animation, and we'll call this idle right. Add frames, open the basic character sprites once again, and then add the last two frames. And we'll just play that. And for each of the animations, we'll keep looping on. Now, as we play the animation, it is a little quick, so let's just reduce that to 3 frames per second. And let's just set that for each of those animations. Now add a new animation, and let's add the animations for each of the tools. Add a new animation and call this filling front. Add frames, and we'll choose the character sprites this time. So we'll change the horizontal to be 2 and increase the vertical so that we've got 12. Choose the top 2 and add those frames. Let's just play that. Let's stop that and reduce the frames per second to 3. Then add frames again and rename this to filling part. Add the frames, choose the character sprites again, and then choose the next 2. We'll change the frames per second to 3, add new animation, call this tilling left, add the frames, character sprites, open, and then we'll choose the next sequence of frames. Play that and just stop and change the frames per second to 3. Add new animation, tilling right, add the frames, character sprites and open, and then choose the next frames in the sequence for tilling right. Change the frames per second to 3. And let's do the same for the axe tool. So add new animation and rename this to chopping front. Add frames, choose character sprites and open, and choose the chopping animations. So we just zoom in on there, you can just see those a little clearer, and add those 2 frames. Let's change the frames per second to 3 and add a new animation. Call this chopping back, add the frames, character sprite, and we'll choose those 2 animations. Change frames per second to 3 and add another animation. call this chopping left, add the frames, character sprite, and choose the two animations. So add those frames and change the frames per second to 3. Add another animation, chopping right, add frames, character sprites, and open. And we'll choose the chopping right animation and add those 2 frames. Change the frames per second to 3. So click add animation and rename this to watering front, add frames, choose character sprite, and then just zoom in and choose the watering front sprites, add the frames, and change the frames per second to 3. Add new animation and say watering back, add frames, character sprite, select the sprite, and add the frames. And then just set this again to 3 frames per second, add animation, watering left, add frames, character sprite, open, and choose the watering left animation and add those 2 frames. And then choose 3 frames per second. And then add the last animation for watering. We'll call this watering right. Add frames, character sprite, and then choose the last 2 frames in the set. Add the 2 frames, and then set 3 frames per second. Now for our last set of animations, we want the character to walk. So add animation again, and we'll say walk, front, add frames, but choose the basic character sprites this time. And we want the top 2 sprites here. So we've got walking front, back, left and right. So add those 2 frames, 3 frames per second, add new animation, walk back, add frames, basic character sprites and open, and then choose those 2 sprites. Change that 3 per second, 3 frames per second, and then add another animation. Walk left, choose the basic character sprites and open, and then choose the left walking animations. And then change that for 3 frames per second again. And then for the very last animation, we will use walk right, add frames, basic character sprites, and choose the last 2 frames in the set. Add frames, and then change this for 3 frames per second. Now that we've completed all the animations, we'll just select idle front just to reset the animation here. Then let's just click on animated sprite 2D, and then using the arrow keys, we can move the sprite so that it sits on the x-axis. So we'll just sit those feet there on the x-axis. And then here we have a message that informs us we need to add a collider. So we'll add a collision shape. So we'll use collision shape 2D, and in the shape option, just click this and choose new circle shape. And then we'll just click and move this up. Just drag that. You make it a little bit smaller, and then it just covers the player. So before we move on to creating the player state machine and all of the player states, let's just go to the test scene player and add our player to our test scene. So go to the scenes folder, and in the character player folder, just drag the player onto the scene. Then let's run the current scene here. And as you can see, the player is now on our test scene and the animation is now playing. Let's close that window. Now, before we create our state machine, let's add some of the keyboard input so we can allow the player to walk. So go to Project, Project Settings, Input Map, and add new action. So we'll say walk up, add, click the plus key here, and then click the W key, then add again, and click the up arrow key. Then add a new action and say walk down, add, click the add button here, click S, OK, add again, and the down arrow key. Add another action, walk left, add, and then add key to listen for the input, and click A, OK, add, and then the left key. And then for the final action, we'll say walk right, add, and then listen for the input, so we want D, okay, add again, and the right arrow key. Okay, so this sets up our inputs. Let's just close that and then save all. Now that we have set up our inputs for our player, we can head over to the player scene and we can begin creating our player state machine. The state machine makes it easier to create the actions that the player requires, such as walking, tilling, watering, and other actions for the player. We could create all of these actions using a state machine in a single script. However, I'm going to show you how to create a state machine using nodes, and each action will have its own state node. And you will see that when we use the state machine, you'll have better control when you transition from each action to another action. I have covered state machines in previous tutorials, so I'm going to ask you to download 2 scripts from my GitHub. We can install those 2 scripts into this game, and then I'll explain the functions once more. So head over to my GitHub. I will leave the link in the description below, and download the node state GD file and the node state machine.gd file. And this can be found under tutorial components and scripts, and this state machine here. So let's begin downloading those. So just click on the file and then just click download file here. And then go to node state machine and just click and download the file again. Once you have downloaded the node state machine script files, go to the root folder. Let's create a new folder and call this script. In the scripts folder, create another new folder and call this state_machine. And then drag and drop the files inside of the state machine folder, and this will copy the 2 scripts over, so we can then view these. When we use the node state machine script, the initial node state will hold the very first node, and then the node states will hold all of the other state nodes. The current node state is which current node are we currently running, and we also hold the current node state name. When the game begins, the children of the state machine node will be held in this array here. So we hold the node state and we then connect the transition to method, which enables the node to transition from one node to the next. Then in the ready method, when the initial node starts, we will enter into that node. The process method is then called as the game runs, and we get the current node state, and then we go into the onProcess method of the current node. At the same time, on the next frames, the physicsProcess method will be called, and we will run the onPhysicsProcess method of the current node, and then we will go to process the transitions. So this is a new method in this state machine, so we can separate the input checking, which allows us to then navigate to another state if those input conditions are met. The transition to function allows the node to transition from one state to the next. And as we get to here, we will exit state node and then we'll enter the next node. In the node state, this class is attached to each of the state nodes in the state machine. We have the onProcess, onPhysics, onNext transitions, onEnter, and onExit. However, these methods are overridden, so we will use this script class to then attach our own methods inside. And as you can see, the onPhysicsProcess method here is what we call here. So we have this onProcess, onPhysics, onNext transitions, onExit, and onEnter are these methods which are being called on the actual state node. Once we have created the state machine and added the 2 nodes, which is idle and walk, I will show you how to debug the state machine so that you can see how those methods are being called, and that will help you when you create your own state machine for future player characters or NPCs, and then you'll be able to adapt this state machine and create your own state. So click on the player node, add child node, and just choose node itself. Let's rename this node and call this state machine, and then click and drag the script and drop it on the node. Then add another child node, choose node again and create, and we'll call this idle. Then add a script and we'll call this idle state. Now in the state machine script folder, open node state script and then just copy everything out of there and go into the idle state script and paste that in. We now have an error message where the class name is. What we want to do is copy node state and just replace node with that, and then just remove the class name because we want to actually extend node state here, and then just remove these two items here because they are actually in the node state class. So if you press Control, hover over the class name and click it, you can see that it extends from that. Go back to idle state script and just save that. In the idle script, we now need to export two variables. So type @export for player and character body 2D. And another export variable, which is the animated sprite 2D, animated sprite 2D. Then on the state machine, let's assign the initial node. This will be idle. And on our idle node, let's assign our player and assign the animated sprite 2D. Then let's add another variable called void direction, which is a type vector2. And in the onPhysics process, we will say if input is action pressed walk left, then direction equals vector2.left, else if input dot is action pressed walk right, then direction equals vector right, else if input dot is action pressed walk up, direction equals vector2.up, else if input dot is action press walk down, direction equals vector2.down, and finally else direction equals vector2.0. Then we need to say if direction equals vector2.up, then animated sprite 2D dot play idle back, else if direction vector2.right, then animated sprite 2D play idle right, else if direction equals vector2.down, then animated sprite 2D idle front, else if direction equals vector2.left, animated sprite 2D play idle left, and finally else animated sprite 2D play idle front. So first we get the input action from the user, and the player will then turn the direction left, right, up or down, and then we'll take this direction and play the associated animation for that direction. Let's save that. Now let's click the test scene player or load this from your scenes test folder, and then let's run that test scene. And if you see the player here, let's now use the WASD on the keyboard. And if you hold the key down, you can see that the player now turns in the correct direction. So let's just close that window. It is also possible to debug your script if you just put a breakpoint on line 13 where it says input.isAction press walk left, then run the test scene again, and you can then use F10 on the keyboard, or you can use these options here to step over a step in. So I'm just using F10 on the keyboard and I can see what my options are on here. So it's currently going into direction 0 on here. But what I'm going to do now is I'm actually going to put the breakpoint on 18 so that when I do press the input is action up, I want it to land on this direction here. So press F12 to keep running. Now I'm holding the D key for right, and when I press the W key, it will instantly hit this breakpoint because this condition here is met. So you can debug your code by just popping breakpoints on here and then just running the test scene here. So let's press F12 again, and let's just close that window. Now before we move on to the walk state, we're going to refactor this code first because we are going to use this in multiple places. So we don't want to keep copying ourselves when we've got the same type of code. We can reuse that. So let's head over to our scripts folder, and we'll create a new script here, and we'll call this GameInputEvents, and just create that script. Let's open it. Let's just remove this top part here and call this class name GameInputEvents. So we're going to create our own class for this, which will allow us to add these methods in there. Just remove the content here, and we'll call this movement input. So we'll create a static function, movement input, and that will be a type of vector2, and we'll return the direction out of this method. Then go back to the idle state and copy the code from that method into here. Then add a variable static for direction. That will be a type of vector2. And as you can see, that has rectified those error messages here. And we still have an error message here because it is expecting us to return a type of vector2 out of this function. So we just return here, and then we can say return the direction. So this function has been strongly typed. We are defining what we would like to return as a type. And the direction here is vector2. So if you change this to string, as you can now see, direction isn't of type vector2. So you must return vector2. We'll add another method in here which will help. So it says static function, and we'll call it isMovementInput, which will return a bool, and we'll check if the direction is equal to 0. Let's return false, else return true. So the isMovementInput function will just determine if the player is actually moving. Now head back to the player and click on the idle state script, and we can now delete this bit of code here and just say direction equals GameInputEvents dot movement input. We can then go to test scene player and test the scene again, and just hold the key down just to quickly test that that is working, and just stop that. Now we are ready to create our next state, so head back over to the player. Let's add another child node to the state machine. So add child node, choose node and create, then rename that to walk and attach a script. We'll call this walk state and save that into the player folder. Let's open the script, and then we'll go back to the node state script, and we will copy all of the methods out of here like we did with the idle state. So go back to walk state, and then just overwrite everything in there. Then copy node state and paste this over node, and then just delete that class name, and then just remove those two items at the top because we are extending the node state class. So let's begin by adding our export variables. So say var player character body 2D, at export again for animated sprite 2D, at export again for speed integer equals 50. Then in our onPhysicsProcess method, we'll say var direction vector2 equals GameInputEvents movement input. So we're using our GameInputEvents movement input function to get hold of the direction, and we're using it as a strongly typed variable for direction. Then we'll say if direction equals vector2.up, then animated sprite 2D play walk back. Then we'll say else if direction equals vector2 right, animated sprite 2D play the walk right animation. Else if direction equals vector2 down, animated sprite 2D dot play walk front. And then elif direction equals vector2 left, then the animated sprite play will walk left. As you can see, this code is the same as the idle code here, except we're going to use different animations. Now the last thing to apply is the velocity. So say player.velocity equals direction times by speed, and say player move and slide. This should then allow the player to move as we start to change the direction using the WASD key. So let's head back over to the idle script, and what we now need to do is to transition to the walk state when we are moving. So in the onNextTransitions method, we will start to make some changes here, because if we look back at the state machine, because after the onPhysicsProcess method, we also then check on the on next transitions to see if we have any inputs which we can check against and then transition from one state to the next. So go back to the idle state, and in the on next transitions method, first we'll check if there's any movement input. Then we will check if there is movement input is returning true or false. And then we can call the signal, which is inside node state here, which is registered in the state machine. And we can say transition and then use the walk state. Now click back onto the walk node, and on the player, just click assign and assign that player node to the player variable. And for the animated sprite 2D variable, just assign the animated sprite 2D. We are now ready to test the scene player. So click on test scene player and let's test the scene. And before we press any keys on the keyboard, the player is currently in the idle state. And if we just press a key, we can see that the current state is walk. But when we release the key, it doesn't go back to the idle state. So let's just stop that. We'll head back over to the player, and in the walk state, in the on next transitions function, we'd like to say GameInputEvents is movement input is returning false using the not operator. And if we're not moving by using this, then we want to transition back to idle. Just save that. But first of all, I just want to make a quick modification to the state machine. I'm just going to copy this print statement here, and I'm going to paste it in the physics process method so that we're always pushing out the current state to the output window. Save that. Let's go back to test scene player. Let's run the test scene. Now hold the D key, and as you can see in the output window just below the game window here, you can see we're now in idle, and then we're in walk, idle again, up walk, we're walking left, release, back into idle. Okay, so let's just walk right one more time. Now when I release, the player faces forward. Let's go left, release, and the player is facing forward again. Let's fix that so that when you release, the player stays facing in the correct direction. So if we look at the walk state, we get our direction from the GameInputEvents movement input function. However, in the idle state, we also do something similar here. So what we need to do is to get the direction when we are in the walk state and then store that so that when we then go back to the idle state, we only pull the last direction state which was saved at the time. So it is possible to do that by storing a variable on the actual player itself. So select the player node and let's create a new script. So attach a script and make sure the template is off because we want to just create an empty script, and then we'll create that. So just open the script, and inside of the script, let's create a new variable. So we'll say for player direction, and the type of that is vector2. Now head back over to the walk state script, and after the last else if, we can say if direction is not equal to vector2 0, then player direction equals direction. However, if you notice, when you type player direction, it doesn't appear in the IntelliSense. And this is because we're using dynamic types. So if you go back over to your player script, this variable can't be found because we need to give this a class name. So we can say class name player, which derives from character body 2D, and the player will now have the variable player direction. So we go back to walk state now, just save everything first, and then save player.player direction. So it's still not there, and this is because we're still only using character body 2D. So let's use that class name as player, so you can now see that it's here, and it's got the same icon as a character body 2D, because if you go back to the player script, the class is a player, which still extends from character body 2D. So player has player direction and everything that character body 2D has as well. So let's go back to walk state now. We've changed this to player, and we see player direction equals direction. So we now have that IntelliSense. And that has been made possible by using class inheritance. Now that we are storing the player direction in its own variable and assigning this from within the walk state, we can now make a modification to the idle state. First, in the idle script, let's just change this player to say player here. Then remove this first line here and then say player dot player direction. And then just copy this over the direction items as such here. We can also remove the local variable as well because we're getting the player direction from the player here. Now in the idle script, as we transition from idle to walk and then back from walk to idle, we just want to stop the animation. So we just copy the animated sprite 2D, and then when we exit this state, we just want to stop the idle animation, because as we go into the next state will handle its own animations. So on exit from the idle state, we'll stop that, and then we'll go to the walk state, and when we transition back to idle, we'll exit again. So we just want to stop the walk animation too. So I'll head back over to the test scene player, just go back to the test folder, load test scene player, and then let's run that test scene. So let's hold the D key down so you can see that the current state is walk. But as you release the key, the idle state is in the correct direction. So let's go up and the idle state is correct. So we're in walk, and then as we release, the character is facing left and then forward again. So we've now resolved how to store that player direction and use that in other states. Let's just stop that. Now that brings us to the end of this tutorial on how to create a player with a state machine and two states, which is idle and walk. In the oncoming tutorials, you'll be advancing on the state machine to create different states for chopping trees, tilling the land, and watering the crops. I hope you've enjoyed this tutorial. Please hit like and subscribe to receive notifications of all my tutorials and latest updates. Thank you for watching.